Everybody, namaste. Today I am going to show you a video about solution of some selected topics from the chapter Pressure of Compulsory Science for grade 10. I have selected two questions here, and these questions are important questions for SEE. We start the solutions of first questions. Solution of 1. Look at the questions. The first question consists of 4 sub-questions. First questions. Study the given diagram and answer the following questions. And the sub-questions are: write the name of the diagram, and second, on which principle does it work? Write the principle. And third questions, calculate the value of L if 240 Newton force is applied on piston A, where cross-section area of piston A and B is 40 cm square and 0.8 meter square respectively. And fourth, can we use gas instead of liquid? Give reason. We have to give the reasons for the 4 questions. So we start from the sub questions I. Okay, and that first sub question, write the name of diagram. That means the name of instrument. Okay, instead of diagram, it may be instrument. Okay, so the name of this instrument is, I think you have guessed it, or you know this in your regular class, because this video is to revise you during the lockdown period. So I go very shortcut. So write the name of the diagram or instrument. The name of the instrument is hydraulic press. Okay, the name of the diagram is hydraulic press. Now in the second part, on which principle does it work? Obviously, the principle is Pascal law. Hydraulic press is based on Pascal law. Now, what is Pascal law then? You have to write that principle, okay, or the principle of Pascal law. So, the statement of Pascal law is when a pressure is applied on a liquid contained in a closed vessel. It transmits in all direction equally and perpendicularly. Okay, this is the statement of the Pascal law. You can write the definition according to as in your book. Okay, or in shortcut, liquid pressure transmits in all directions equally and perpendicularly. When a pressure is applied at a place of closed container containing the liquid completely. Okay. So now on the basis of this Pascal law, we have so many equipment, that excavators, cranes, these all are based on the Pascal law. Uh, Hydraulic brake, hydraulic leaf, all these based on the Pascal law, because liquid is incompressible, and so if we apply pressure at a place, then it transmits in all directions. That means the force is multiplied. Okay, so suppose this is an equipment having 3 pistons. Similarly here, 4 pistons. If we apply a force here by 10 newtons, then the same force is transmitted to all directions. Okay, 10 newtons. Here also 10 newtons. If you assume that the area of these all pistons are equal, then this 10 newtons of force is applied in all directions. When it is applied, then it transmits in all directions. So the 10 Newton force is, becomes 10, 10, 10, 30 newtons. So liquid is considered as a 4 multiplier because it is incompressible. But in case of gas, it is not possible because gas is compressible substance. Gas is not incompressible, that the gas cannot multiply the force, but liquid is incompressible, so it can multiply the force. So we can use liquid in such equipment like hydraulic press, hydraulic brake, hydraulic crane, hydraulic lift, etc. Okay, so many equipment that we see around us, excavators, brakes. In motorcycle also, we have liquid brakes. Okay, now we solve the question number 3rd. Calculate the value of L if 240 Newton of force is applied on the piston A. So look at here, in the piston A, 240 Newton of force is applied. Okay, and what force should be kept at piston B to balance these 240 Newtons? Okay, so we have to calculate the value of L. So here in 3rd case, the area of piston A, that is say A1, equal to 40 cm square. Similarly, force on piston A, say it is F1, it is 240 newtons, and another area of piston B, say it is A2, it is 0.8 meter square. So look at here, cm square, meter square. It is a different form of the unit of the area. So we have to change them, or we have to make them same. So changing this meter square into cm square, we we have to multiply the meter square by 10,000. Now it becomes cm square, because meter square, that is m times m. 1 meter contains 100, so each meter contains 100 times becomes 10,000. Okay, when multiplied by this 10,000 and 0.8, we get 8,000 cm square. So finally we have to find the value of L. Value of L. That means force on piston B. Okay, that is, say it is F2 equal to what? Okay, now from the Pascal law, we have a formula. Okay, so we can solve it in the first part. Okay, you have up here, see here. Solve it here. So go here. So from Pascal law, F1 by A1 equal to F2 by A2. So the value of F1 is 240 and value of A1 is 40 and F2 is, we have to find, that is L. You can write L, yes, and the area of piston B is 8,000. So by cross multiplications, L equals to 40 times 8,000 divided by 40, and this gives 48,000 Newton. So the value of L is 48,000 Newton. Okay, this completes the third part of the question number 1. So to balance 240 newtons, 48,000 newtons of force should be kept on the piston B. So look at here, only 240 newtons of force produces 40,000 Newton force. So with a small force, we can lift up a large weight. Like in excavator, cranes, and in a garage. These instruments has an important role. It is based on Pascal law. Okay, now we discuss the second questions. Let us clear it. Oh, no. We have left one more questions. I have told you at the beginning that, can we use gas instead of liquid? Listen, both gas and liquid are fluid materials, as they have weight and they exert pressure. But one thing is different, that is, liquid is incompressible whereas the gas is compressible. Okay, so the fourth questions, gas is compressible and liquid is not compressible, that is incompressible. Okay, so gas cannot multiply the applied force in closed condition, but the liquid can multiply the force in closed condition. Okay, hence gas cannot be used in hydraulic press, and in the other cases, hydraulic jack, hydraulic garage lift, etc. Okay, so this is the reason why gas is not used instead of liquid. Okay, this is the answer of both questions. Now we discuss the question number 2. Okay, let us clear it. So let us see the question number 2. Study the given diagram and answer the following questions. Okay. We have three sub questions. List the name of the apparatus used in the diagram. Write the principle associated with this diagram and find the weight of the displaced water, and also find upthrust experienced by the object X. So first answer right here. Solution of 2. I list of apparatus. The first one is, you can write any one of these at first. This one is spring balance. Spring balance. Okay. And this is the Eureka can already given here. You need to write. And this one is the beaker. And this one is the pan balance. B, C. Pan balance. Used to measure the weight of the displaced water. So look at it now. So now we solve the question number 2. Write the principle associated with the diagram, with this diagram, and this diagram is associated with the Archimedes principle. Okay. Archimedes principle. The diagram is associated with Archimedes principle, and the statement is the Archimedes principle. When an object is immersed completely or partially in the liquid, it experiences an upthrust equal to displaced liquid by it. Okay. This is the principle of Archimedes, and you can write the principle according to as your note or book. Okay. Now we solve the second questions, not third questions, final questions. So find the weight of the displaced water and also find upthrust. So before solving that, we discuss about this diagram. Okay, when this object X is in air, the weight is 25. This spring balance shows 25 newtons. Okay, 25 newtons. And when it is immersed into the water, then the weight is reduced and it becomes 23 newton when it is immersed into the water. And why reduced? Because of upthrust, given by the water to this object. Look at here, this object, and upthrust is given by the water to that object. And because of this upthrust, the weight of this object X is reduced to 23 Newton. Okay, so the reduced weight is obtained by subtracting the weight inside the water from the weight in air. Okay, so when we lift up some things inside water, it is easy, but when it comes outside the water surface, it becomes some harder than inside the water. It is because of upthrust inside the water. It is easy, but in outside there is no upthrust of water, but there is a upthrust of air which is negligible. So it is harder to lift in air, but inside the water it is easy because there is upthrust which reduces the weight. Okay, that is why easy inside the water. So how much weight is reduced here? 25 minus 23. So here weight of object in air, that is 25 Newton, and weight of object inside water, that is 23 Newton. And the difference, reduced weight, sorry, you don't write like that. Weight of displaced water, you put this, you see the, you can go weight of displaced water, that is what? So we know that you write the relations. Weight of object in air equals weight of object inside water plus weight of displaced water. Okay, keep in mind this relation, the most important relations. Weight of object in air equal to weight of object inside the water plus weight of displaced water. Because the reduce, that the upthrust reduce the weight of the object, and this upthrust is equal to the displaced water by Archimedes principle. So upthrust and this displaced water must be equal by Archimedes principle. That is why 25 minus 23 equal to weight of displaced water or upthrust. So now we write weight of the object in air, it is 25 equals weight of the object inside the water, it is 23 plus weight of displaced water, weight of displaced water. So this gives weight of displaced water equal to 25 minus 23, that is 2 Newton. So always solving this kinds of solution so problem, you write these relations and write the given information and find this. Okay, and after finding the weight of displaced water, then we have obtained one of the solution, displaced water. Now we have to find the upthrust. Okay, again you see this here, again by not Pascal, sorry, Archimedes principle. Okay, upthrust equals weight of displaced water, and this equals to Newton. Okay, this is the final answer. This is also the final answer of third questions. Okay, this is the solution of question number 2. Okay, I've made one more questions here. Study the diagram and answer the following question. First, write the principle associated with the diagram and find the weight of the object. This is the object. So, look at here. In this diagram, the object is floating in the liquid. Okay, the object is floating in the liquid. So, the object that floats in the liquid displaces the water equal to its own weight, which is called law of flotation. So, the solution of first answer is law of flotations. Okay, and it said that the objects that floats on the liquid displaces the liquid equal to its own weight. And this is the statement of law of flotations. Okay, so first answer is that, and second answer, so it is obviously clearly from I, the object has displaced 5 Newton of water. So the weight of displaced water is weight of displaced water is 5 Newton. Therefore, by law of flotations, weight of objects, weight of floating objects, because the object is floating, weight of floating object equal to weight of displaced water, and weight of displaced water is 5 Newton. This completes the solutions. So I have modified the question number 2 as this. Study the diagram, answer the following questions, write the principle associated with the diagram, this one, find the weight of the object. So immediately by this law, weight of floating object is equal to weight of displaced water. So 5 Newton. Thank you for watching this video.